All right, hey everyone, if you're watching from a recording, this is the um, last tutorial in advanced track for testing in Unity, and specifically it's unit testing or sort of testing like very specific modules of your program, typically all automated. And this is all done through Unity's testing framework. I don't know if it really has a specific name, but it's all kind of vanilla Unity. You can go get it on any project you want, and it'll essentially help you to create a set of tests to run against your program and to kind of run them automatically in the background, so you can kind of always make sure that your project is working the way that you intended it to. And so I'll just start it off. If you haven't already, please download or at least, I guess we'll go through it in more detail later, but for now, if you can get open the GitHub page, that would be great, because we're gonna be downloading the package from there and then kind of working from a test project in there. But so I think it's useful to kind of just go over very briefly about what it means to test something. Essentially, just like you've seen in all your other classes, all your other CS classes, it's essentially the same thing. You have the contract that you need to follow that's perhaps specified by someone higher up, like an architect or something like that. And it's sort of your job as the programmer, as the implementer, to make sure that whatever you do, you follow that contract. It's kind of like you have to trust that whoever is giving you that contract knows what they're doing, knows all the inputs and outputs, and as long as you do your part, everything else will work together cleanly. And even if the contract seems really whack and stuff like that, you just kind of have to have faith that the architect has accounted for that and knows where all the connections are going. It's just your job to make sure that your module is doing exactly what you said you would do according to the contract. And so I just kind of listed out sort of the things that you'd look into when writing your test cases, things that you'd want to check to make sure that you're following on, things to make sure that you check to make sure you're still on track with the contract. So, for example, and once again, this is just stuff you've probably heard a lot before, but making sure that the normal case is good, right? What you're getting the behavior that you'd normally expect. Edge cases, making sure that those are handled properly, and also how to handle errors. And all this is specified usually in a spec sheet provided by, like I said before, an architect or whoever's sort of creating all of the modules and kind of fitting them together on an upper level. So I just kind of wanted to go an example into what it might look like in Unity. For example, health is a system that's pretty much used in almost every game that you'll see. And so I just kind of wanted to walk through an example of what it might look like to test a script that's responsible for managing the health of a character, right? So this is a script that would sort of kind of wrap around some sort of health stat, right? So HP, like you might have 100 health or whatever, 100 out of 100, whatever. And then it's through this module that other scripts will go and modify that health. So for example, if you get hit by an ability or something like that, you might want that ability is probably going to go and tell that script, your health script, to go and subtract a certain amount of health from whatever it hit. That's essentially its main job. I also listed some other things it could possibly do, like sort of notify the UI whenever it detects a change in health. I do that a lot in a lot of my projects. I have it hooked up with some events so that UI and all their systems can get notified when health gets decremented. But yeah, that's aside from the point. The main thing is that it stores health, and it's the main script you use to modify health. And so this is, once again, not this is not what a real specification would look like completely. It's just sort of just to give you an idea of what it means when we specify, when you get a certain specification for different parts of a module you're supposed to implement. So for this health script, we'd want a function called take damage, which will go and modify whatever health you have by a certain amount. not specifying anything else in terms of return value, just straight up modifications. The other two functions, or I guess accessors that you call, you have health and max health. Self-explanatory, just used to retrieve the current player's health and the max health. Retrieve and sort of set. So it's a getter and a setter. And then once again, to account for the events and like sort of notifying other systems, you have this event called onHealth changed, which is basically an event that's going to get broadcast whenever the health value is changed by anything. And so once again, so this is all sort of high level. This isn't actually what the code looks like, but this is just to give you an idea of what we're going to be doing in just a bit. This is what it sort of example tests that you might run to make sure that in particular the take damage function is doing what it's supposed to be doing, which is, storing health and allowing other scripts to modify it properly and in a defined way. And so, of course, that first test you see here does health decrement by 10. That's kind of testing the normal case testing to make sure that it's, it's actually decrementing a value by 10. And this could be 10, 20, 30, 40, whatever. It's just to test the functionality that we're decrementing something by an amount. And then those other tests that you see, does health stop at 0 and does health stop at max, are sort of tests to make sure that the health value that you have is sort of capping at the right values, right? Like if we have a player with 50 health and he gets hit by like a 1,000 damage missile or something like that, we don't want him to be negative 9,950 health. We want him to be at 0 health. For whatever reason, it might be because negative values might break the game or other parts of the game, or you might have UI that kind of stops at 0 and you don't want it to go the other direction or something like that. Whatever the case, those were kind of the specifications for take damage, which was we want to kind of cap it between 0 and some maximum range, or some maximum health value, sorry. So finally, going into now what it looks like. So far you've seen sort of on a conceptual level, high level, what testing is supposed to be. Now we're going to kind of look at how we're going to do that in Unity, what it sort of looks like, how we're going to get these tests to run. And there you go. It's very, very simple. Just like other unit tests that you've seen in other CS classes or whatever, it's just a simple function, or rather a set of functions that Unity is going to go and run in the background and go and run and sort of run all these assert statements to make sure that your program's not crashing, or rather it will crash your program if those tested values aren't what you expect them to be. And so this is sort of an example of one of the test cases that we looked at for just a few slides ago. Does health stop at 0? So if you remember this test, what we wanted to do is we wanted to make sure that we're not sort of decreasing all the way past 0 to make things still make sense. That's just the behavior that we were getting. And so you can see here, some code is taken out, like sort of the initialization stuff, but the core of it is that we just have a health stat, right? We have our object that's holding our health data. We're going to remove some health from it. Something I didn't note in this example is that the health stat is initialized to have 100 health. So, right, we have 100, we're going to do take damage 101, and we should expect that it stops at 0, not at -1. And so we have that assert statement afterwards that sort of essentially checks to make sure, like our expected value, you can see the first one is 0, and then we pass in our actual value that we have, and we kind of compare them. And assert essentially comes with a whole bunch of these tests that you can do. So there's like is greater than or something like that, r equal is null, stuff like that. I didn't list them here, but you can find them pretty easily, especially if you have IntelliSense. You can just type in assert and then dot is something, and then they'll all pop up. Yeah, assert is what you use to verify that your test is passing. And so in Unity, it's kind of interesting because there are sort of two types of categories of unit tests. There's edit mode tests and play mode tests. And what edit mode tests are essentially what you typically think of as a unit test in any other field, really. It's this is a unit test, right, or this is an edit mode test right here. Essentially, it's working on static behavior. So it's useful for testing things like if your calculation's coming out correctly. Maybe you have some algorithm that you want to check to make sure that it's I'm going back into CS32 stuff, but like if you have an algorithm that's sorting things in the right way, it comes out sorted properly. This is to test things that are I kind of want to say almost like purely computational. Um, and so this is great for a lot of things where I mean that's the main focus, computation, right? If you're doing things like I said before, if you remember from CS32 or from Smallborg or whatever, you have these functions that are supposed to run algorithms in the background and take in like an input and get back an output, a clear input and output stage. This is what it's for. And the problem with this when it comes to Unity is that games are dynamic. There are so many different things that come into play, right? You have your physics system, you have collisions, you have this guy over here and this guy over here, and they might have some weird interaction because in this frame this guy moved a little bit forward, but this guy didn't, or whatever. And so you can imagine that edit mode tests or kind of your standard unit tests wouldn't really work out too well because they're not meant to handle that sort of complexity that we have when it comes to like sort of these really complex game interactions. And so what Unity has for that are play mode tests. And what play mode tests do are is essentially they almost like simulate the game, like they sort of run the game, but in a very constrained way. And those constraints are set by you, right? It's essentially like you can imagine as like you sort of create like a test scene, like this play mode test, right? Will create a test scene, and then it'll spawn in just the objects that you want to test, right? So maybe you have your character over here, you spawn in a meteor over here, and then you let it play out, and you see if when the meteor hits the player, I don't know, a death particle spawns or whatever, something like that. It's essentially play mode tests, as their name suggests, are essentially almost like mini simulations that you run. You're actually like playing the game, or you're actually running the game and seeing things and having things move in real time. Ideally, you'd want these tests to be sort of short so you can like run a lot of them. Like instead of having spawning the meteor all the way over here and the player all the way here and waiting for it to come crash, you might spawn the meteor just like literally pixels away and then just have it crash and then test that collision is triggering or something like that. But you can imagine you can't really do that too easily with edit mode tests or your standard unit tests. So we have these play mode tests. And so with that, all that high level stuff out of the way, now I kind of want to go into practical stuff. Actually getting to do the stuff that I just talked about. And so this is where the package is going to come in play. If just go to the GitHub page under testing in Unity, and you should just see the README and then download the package here or whatever. I'll kind of step through it on my screen too, in case you can't follow along too well. But you're just gonna kind of load up the test project, and we'll try to write some of these unit tests that I just talked about. And I'm going to go over the first one by hand just so you can see the process of making one, because there are a few steps that you need to follow in order for everything to work out. And I just wanted to point out that, once again, if you don't catch it all the way, at the very end, I have sort of some videos that you can watch that kind of go through this too, so you can pause it and look through it yourself. But I'll do it by hand right now. So let me just, I'm gonna start sharing my entire screen so that I can get Unity in there. Okay. So this is just a plain old Unity project. I didn't add anything to it. This is, I think, just like the default 2D Unity project or whatever. And then I already downloaded the GitHub file, but if you don't remember, it's just let me just go to the very beginning and go here. It's just under this README over here, import this package, and then you'll be taken to the Google Drive and you can download it. But so once it's downloaded and you have your new Unity project open, just go over to the left and go to Assets, and then Import Package, Custom Package, and then select the package that you just installed. It should be called Advanced Track Testing Tutorial, and then import everything, and then you should be arriving at the main scene. So you'll start off on the sample scene, just go over to the main scene. And it's just a simple project where you have this sort of punching bag guy, and then if you press space, he takes damage, right? And then once he hits 0 health, he just explodes. And so this is just sort of a very simple project to serve as a way to test simpler things, to test individual components of it. In particular, to go along with what we were looking at before, just wanted to go over the testing the health specifically. And so the process for creating our test scripts is a little tricky, so I'll just go through it a little slowly. So the first thing that you'll notice is that I have a test runner little panel thing over here, and I believe it's not there by default. So I'm going to close that. So your screen might look like this. And so our test runner is essentially a panel that's going to let us run these automated tests. And so to get there, I believe we go to, oh wait, yeah. So right click anywhere and then go to create. And then I believe it's, oh, under testing over here. So right click, go to create, and then testing, test assembly folder. Wait. No, that's it. That does not sound right. Sorry, I think I believe it's, yes, sorry about that. I mixed it up with something else. You go to window and then under general, and then test runner here. So Windows is going to have all the things related to different panels you might need, and of course that's test runner. I didn't think about that. So yeah, so you're going to kind of get this panel called test runner, and you can kind of dock it on the side, the left. I just keep it over there. And so it's going to prompt you to create a test assembly folder. Essentially what this test assembly folder is going to do is just going to house all of your scripts that are used for testing. So it's going to kind of be separate from your main scripts. And so what you can just do for this project is in your assets folder, you can make sure it's on edit mode, or you can do play mode, but I guess for now we'll just go edit mode, click on edit mode, make sure it's selected. And then right here it says create edit mode test assembly folder. I'm just clicking on the button here. It'll automatically create a folder in whatever file that you're in, or whatever folder that you're in right now. Right now I'm in the assets folder, so it's going to create a folder right there. And we can just call it edit mode. You can call it whatever you want, but just you just need a name that kind of will distinguish it and let you know what you're doing. And then we're going to create another one for play mode. So that was edit mode. And yeah, so that was edit mode. And now we want to create one in play mode. So same thing, click on that button on the side. Make sure you click on play mode in the test runner. Oops. Okay, yeah, it default made a folder. Okay, let me call this play mode. Okay, and so you'll have these two folders. It'll recompile a little bit. You'll have these two folders that are meant to hold your edit mode tests and your play mode tests respectively. And if you just a refresher, edit mode tests are sort of what you typically think of as unit tests, and play mode tests are the ones that Unity sort of made in order to help you do unit testing in Unity, where it actually kind of resimulates your game and has things move in real time. So we're going to start off doing the edit mode test. Oh, sorry, one more thing, which is kind of interesting, is that in order for your tests to be able to access all of the scripts in your project, you're going to have to make a reference to all of your scripts, create sort of an assembly reference. Once again, this isn't sort of my area. I'm not I'm a little hazy on specifically what's going on here, but we do create some assembly asset for our scripts. So, and what we're going to do is we're going to make sure that our test folder has a reference to that, just so that our tests can see what all of our scripts are. Without it, the test wouldn't be able to reference any of the classes that we made or anything like that. So we go to our scripts folder and we right click, go to create, and then assembly definition. And you can call it whatever. I'm just going to call it scripts. And so this sort of, once again, not sure of the details specifically, but this sort of holds the information about sort of all the definitions of our classes, all the scripts that we wrote, and it enables our test folders to see what our scripts are and to be able to use them. And so, for example, for our edit mode test, we're going to click on edit mode. So this is our edit mode assembly definition. Once again, hazy on this, but the key point is that you go over and you add a sort of a definition reference over here on the side. So once again, this is just clicking on edit mode and then going over here to this plus button under assembly definition references. And then you can choose to add in a reference. And in this case, we want to reference our scripts assembly that we just created, our scripts assembly definition that we just created. Once again, this is to make sure that our edit mode tests can see what our scripts are and all that. And we're going to do the same thing for our play mode test. Okay. And it's going to sort of ask you if you want to apply, and it's going to recompile or whatever. Now with all that setup done, now we can actually get started writing the tests. So we're going to go to, for our first thing, we're going to try out doing edit mode tests. I believe, I'm not sure which one I had specifically that we were going to do. Oh yeah, it does health decrement by 10. So sort of that, sort of the normal example that you'd see for covering the normal case, making sure all that's working fine. So what you can do is on the left side, you'll get a prompt. So make sure you're on edit mode in this test runner, called create edit mode test assembly. What you can do, I guess if it's not showing up on the left side, usually it prompts you if you want to create a test folder. You can go to create testing. This is what I was looking at before, and C# test script. And I believe now you can just call it test suite or something. Yeah, here we go. When you open up test suite or whatever you called it, you're going to get sort of this really nice template here that sort of walks you through what each thing is. In this case, we're looking at edit mode tests only, so we can remove this section. This is Unity test is the play mode test that I was talking about before, but we'll look at that later. So this is sort of the general format for edit mode tests, which you have this sort of attribute on the top called test, and then you have your test function here. There are a lot of different, I guess, what do you call it? I guess ways of writing, standards for writing, I guess formats for writing, for differentiating test functions from others. The one I saw from, I think, Jason Wyman is you kind of write it like, what do you call this, like snake case, like what Python does? Whatever, something like this, where you have sort of lowercase letters and underscore. You don't have to follow this, you can do whatever. But in this case, what we're doing is we're checking if the health decrements by 10. That's the test case we want to write. So does health decrement by 10? And the thing is, I think this is good practice, is just to really spell out what your test is doing so that you can instantly tell from your test suite what it's actually testing. You don't have to worry about being concise because you're not going to be the one calling these anyways. So let's write it. So what I have provided in this program, or in this project, is sort of the main class that we want to test, which is health stat. And so this is on me. The names are a little confusing, but and we can take a look at the internals a bit later. But right now, just think of health stat internal as the health stat that we were looking at before. So this is the same class that we have that's sort of encapsulating the health and use it to modify things. Health stat internal is just a regular class. And so what we can do is we can instantiate it. If you guys remember, for mono behaviors, you aren't able to instantiate mono behaviors, or at least Unity prevents you from doing it. And so the only reason this works is because health stat is not a mono behavior. And because it's not a mono behavior, we are able to instantiate it. And so what we're going to do in this unit test is first we're going to create our stat, right, the thing that we want to test. And then from here, we are going to initialize it. And I believe there's a way to initialize all in one go. You can just set the data members like this. And I know in general it's bad practice to have these data members exposed and stuff like that. But in this case, I believe since we're once again, I'm not exactly sure how to foolproof test this. Like these are accessors and not and accessors and setters, so they're kind of like functions. But and so we'd need a way to test these first, I guess, to make sure everything's fully tested and stuff like that. But we'll just assume for now that these do what they say they do. They'll set the health perfectly and the max health, whatever. That's sort of an assumption we'll make. So the real meat of this is we're trying to go and now test that we're going to the decrementing function works properly. So we can do that. We're going to call take damage, right? The function that I listed before. And in this case, we're trying to check if it decrements by 10 properly. So we're going to put in 10. And then we're going to go and now check using our assert statement, assert.r equal expected value. We'd expect 100 minus 10 equals 90. And then we'd put in our health stat dot health. And so that's all we need to do. So now if we go back into our main project, we can now see that on our left, or wherever your test runner is, under test suite, you'll have your test out here. So Unity automatically sort of populates it with all the tests that you have in your test suite. So if we created another one below here, that would also go in the test suite here automatically. And the way you run it is you just double click it. And then we can see we get all check marks. It's really fast. Edit mode tests are really fast because they're kind of like your standard unit tests. Play mode tests, on the other hand, take a long time, and that's why we kind of want to try to avoid those, although you can't do that all the time with something like Unity. But yeah, so that's sort of the whole process for making an edit mode test. And part of the, I guess, practice problems or whatever exercises is to make these other two ones. So we just did does health decrement by 10, but now we sort of want to make tests for does health stop at 0 and does health stop at max. And so that's what we'll do for the next, I guess, 5 minutes. If we need more time, we can extend it. But yeah, I'll just be chilling here. We'll meet up again. Zane, I know it's just you, but for everyone else who's watching this, you could pause this or whatever. Just take the time to try and put in these test functions into the class we just made, the test suite, and then try to get so that it appears on the left and make sure that all of them are passing. And see if you can think about like what assert statements you're supposed to use for each of them. I think they're all the same, but whatever. You get the idea. Try to remember that there's sort of the step of creating your the thing you're testing, and then you're sort of initializing it. You're performing some action to it, and then you're testing that the action created a valid result. Those are sort of the 3 steps. And Unity actually has like a way to structure this a little cleaner, but just so that everything's here, I just kind of listed it all out. I can go into the details of that later, but I'll shut up for a little bit now and let you work. But yeah, we'll meet back in 4 or 5 minutes. Funny enough, I use the same health bar in our SRS project that we're working on right now. So if you recognize it from Project Ronin, you'll know where it's from. I literally created it for this project, and now we're reusing it. Just as a quick example, I just changed the implementation so now it's broken and the health goes in increments health instead of decrements it. Uh, and you can see when we run this test, it fails because it does not decrement by 10, it adds by 10. And if you ever, and you can see sort of in this log on the side, whenever your assert fails, it provides information about what failed. You see it is expected 90, but was 100. Once again, it doesn't increase to 110 because the clamping works, but if the clamping didn't work, it might be 110 or something like that. But I just wanted to kind of show what it looks like when you fail a test. Okay, cool. I think we're gonna move on now, just to keep on track with everything. But once again, since most of you guys are gonna watch this recorded, you can literally just pause me, and then you can have as much time as you want. But we're just gonna go get straight into our next test that I wanted to go over, which are play mode tests, um, which are the ones that sort of simulate the Unity environment and have things run in real time. Um, Admittedly, when I made this project, I didn't create a very great example of doing a play mode test because you could sort of argue that it could be done in edit mode, but it's sort of the same thing. The idea is that we use play mode tests whenever there's sort of like a mono behavior that we want to test that's really difficult to test in the form of a unit test. Um, and this happens a lot. For example, like I gave in the slides, let's say you have things that are moving and you want to test that. For example, a collision in the physics system is working properly. You literally have to spawn in an object here, spawn in an object here, and let Unity play out and see what happens after sort of a few seconds. Like you'd sort of wait 5 seconds or whatever, and you kind of check if a collision event occurred or something like that. But unfortunately for you guys, you have to sit through my not as good play mode test example, which is using it as sort of a way to test whether the guy gets destroyed. So if you remember, what essentially what we want to happen when the enemy reaches 0 is we want him to explode. Exploding just means he just gets disabled, and typically this is sort of what might happen like in like a pooling system or whatever. The thing that gets destroyed gets disabled and then gets put into the pool or whatever. You might want more rigorous tests if you actually have a pool. But in this case, what we want to check, we want to write a play mode test that's going to essentially check whether or not the player gets disabled once his health reaches 0. And so the test is called "Is player disabled on 0 HP?" And we're going to do the same thing that we did for the edit mode tests. We're going to go to play mode and then we're going to create where is it? Testing C# test script. You can call it test suite, play mode. I don't know, whatever you want. And then once you go in here, same thing. The only difference is you remove this top portion that says test because that's for edit mode tests. And play mode tests are marked with this attribute called Unity test. And so you can kind of use this as an example. It's an I enumerator, so it's sort of like you can think of it as a coroutine. Essentially what it's going to do is it's going to sort of, as long as you let it, it's going to go and sort of keep cycling through it. You treat it just like a coroutine, right? So for example, if you want something to run for several frames, you'd have yield return, wait for next frame or something like that in some for loop, and then have the loop go like, I don't know, 5 times if you want it to go to pass 5 frames by or something like that. For this particular case, we don't need to use sort of the coroutine functionality. It's just we're sort of using play mode tests as a way to get mono behaviors in the scene. And so it gets a little tricky now how we do the initialization step. So in previously, what we had to do was we just sort of created like a new class, like sort of what you do in any other programming language, and then you go and initialize the values. But now that we're sort of simulating it in a scene, we kind of have to think about how we would set it up in the scene so that we can test these mono behaviors. And so just to start you off, usually what you can do is you can go and create a game object. In this case, game objects can game objects can wait, let me, oh, that's why. Okay, I'm the this is me being way too reliant on IntelliSense. I don't know why it's not, or whatever. I'm just gonna have to wing it. What you can do usually is you can do game object, or sorry, you can create a new game object like this, but then, and that's sort of quote unquote instantiating the game object in the scene. It's not really instantiating anything, but it's creating a game object. And then what you can do is mono behaviors are components that can be added to game objects. So if you have a mono behavior, what you can do is you can do game object dot add component, and then you put in the name of that component. So in this case, you're not going to use health stat internal. You're going to use health stat testable. It's going to look like health stat testable. And essentially, health stat testable is sort of like a wrapper around health stat internal. It's just health stat testable is a mono behavior, and it's not just a regular class that you can instantiate. So this is sort of like us, quote unquote, instantiating health stat or health stat. We can't use new because health stat testable is a mono behavior. As you can see at the top, yeah, it's a mono behavior, so the Unity doesn't like it when we instantiate it. So we can do this, right? And we want to sort of get our reference to it. So we can just do something like that, where we sort of get our reference to the health stat, and now sort of we can get started with all the other things that we wanted to do, right? We can check all of its, we can set it, we can initialize its health, we can damage it, whatever, and then we can check certain things about it. So that's sort of how it starts. And I'll give until 7:50, I guess, 4 more minutes, 4 minutes to sort of think about how to implement this. While we're doing this, let me see if I can get IntelliSense back up. But yeah, so this was our initialization stage. Now we just have to do the kind of the death. How would we simulate a death happening, the player getting destroyed, and then how would we check if the player is disabled or not at the end? Yeah, that's what we'll try to do. You can just ignore this yield return null since we're not trying to play this over several frames. This is something that would sort of happen instantly, which is once again why I think this is not a great example, because it doesn't show that unit tests or these played mode tests are supposed to be sort of typically run with things that happen over several frames. But whatever, you can also use it like this if you can't test it in an edit mode test. While we're doing this, let me see if I can get IntelliSense. Oh, sorry. One key thing I forgot to mention that probably wasn't too clear. The way that the enemy actually gets destroyed is because there's another script. So sorry that this is on me. I should have mentioned essentially what this is testing is not health stat. We're testing another script really called health change reactor. Sorry, this was on me. I should have specified this. Previously, we were testing health stat, making sure that functionality is good. Right now, essentially what we're testing is health change reactor, because health change reactor, as you can see, is the actual one that handles kind of disabling the game object. So what you're going to need to do is you're going to need to go and in the play mode script, create a health stat, what do I call it? Health stat, health change reactor. You can just call it whatever. And then, do the same thing. And essentially, that's all you need to do to add it to get that functionality. If it wasn't working before, that script just needs to be on there at the same time that the health gets kind of depleted. And you should sort of see if you can get that effect going. But we're a little bit over time. Sorry, that was on me, but if you watch this later, feel free to pause and try it out for yourself. Essentially, what you do is you go and you instantiate this thing. So you add it to the game object which we just created. We go and do take damage, right? Or we initialize the health to 100 or whatever. We take damage more than that amount, and we essentially after that we check if the game object's active state is false. And if it is, then we pass the test. I was going to release like a solution thing, but I think it's pretty self-explanatory. But if needed, I can post what the actual test should look like. But I think if you think about it for a little bit, you should be able to to write it out all the way. So with that, that's sort of the end of the little exercises that I had. You can test this out. There are a lot of sites out there that have tutorials that go through a lot of other different tests, different possible tests that you can do, like specifically like with movement and all that stuff. But this is just sort of a very, sort of the simpler tests that you might see. And so you might ask, like, with all this automation, why would we ever do manual tests? And the reason is that games are really complicated. And let me go back to slideshow mode so that you don't see. Anyways, that was supposed to be a slide. Anyways, so yeah, games are really complicated, and you can't do everything cleanly with unit tests. You can try to make a whole bunch of unit tests and test a whole bunch of things, but in the end, there are just way too many like really complicated interactions between different modules and stuff like that that can't be sort of easily tested with unit tests. Like you may test this one specific interaction, but maybe when you add in another enemy later in the game or something, maybe he does something crazy, like he picks you up and he chucks you somewhere else, and you didn't account for that in your other unit test. And so it's just really hard to write good unit tests that sort of cover every single case. I know like unit tests aren't supposed to cover every case, but it's especially true for games where you have all these complex things happening. And sort of it's like sort of almost like, I guess, evidence of this is that like big AAA companies have QA teams, right? They literally have people doing manual tests as their job. And so like if you could solve everything with unit tests, why would they even have QA testing at all? So it's like really important to be able to test things manually, see how a game feels in general, because games are sort of the sum of all these different parts. And a lot of times what manual testing does is it lets you see the game on a high level. It lets you see if your game on a high level is meeting all the criteria you set out to do. And so just wanted to say that manual tests are still important. Don't completely throw them out the window, because unit tests can't really solve everything. And so lastly, why should I test? Tests are really boring, right? They take a lot of time to do, and I don't know, it feels like a lot of times they don't get you a lot of value. And the reason is just because at the last minute, you really don't want to be running into all these crazy errors and stuff like that. I know in my last SRS project that I did last quarter, Splecbot, we didn't really build the game and test it until literally the night before it was due. And we had all kinds of errors, and it was really crazy. We managed to get it out in the end, but we were super tired, and that could have easily gone bad. And so it's really important to have these tests in place so that you essentially check your progress as you go. You find the errors early on in the process so that you have time to fix them. You don't wait until the last minute and see if something's breaking when you build it. And sort of a good thing about Unity, the way Unity handles it right now, or sort of their structure that they have right now. If you're on Unity teams, like if you have what's it called? If you have like a Unity account and you set up a project that's linked to a Unity project, and that project has unit tests like the same ones that we made, you can set it so that Unity will sort of automate these builds for you, right? So it'll like if you push your changes to a repository, Unity is going to kind of take it to one of its build servers and go and try to build it for you and run your unit tests. So it's sort of like testing as you're building too. And that's like a really cool way that Unity helps you to kind of get things flowing really well. Like so essentially that you essentially make sure every time someone commits to a repository, it's passing all the tests and all that. I just sort of started getting into this, so I can't provide a ton of detail about how that works, but I do know it's a thing. We're using it a little bit in our project right now, but you can set up in GitHub so that you see if it's passing all these unit tests. I think you might have to set up some hooks or whatever, but you can get it so that it's sort of looking at these unit tests, seeing if it's passing and it's meeting all the requirements before you actually push it to main. And that way you sort of keep bugs out of your main repository. but I just wanted to reiterate that uh, unit tests don't solve everything. They're great for little small things that are easy to test. I guess my take on it would be is if it's relatively easy to test already, like simple computations, certain algorithms that you're using, go ahead and use unit tests. If it doesn't require sort of a whole lot of modification to make it work, then go ahead and use unit tests to test those things. But when it comes to really complex mechanics that would be a real headache to design a really clean unit test for, I'd say it's not worth the effort, and you should go and try um, sort of drafting up a set of manual tests to do. And this could be things like make sure that when I press forwards, the player goes forwards or something like that. Or when I press right while the player is facing forwards, I want the character to smoothly rotate. Things that you can sort of see visually and verify like that. That's sort of what we're kind of doing in our project right now. We set a list of tests that each of the programmers can do to make sure that their module is behaving sort of in general like we'd expect it to do. Because once again, writing unit tests for everything can be really difficult, especially with complex game mechanics. So yeah, with that, I just want to say thank you guys for coming to this relatively shorter tutorial on unit testing. Main points, just remember that unit tests don't solve everything, but they are a really great practice, and they're useful in some fields more than others. It just happens that in Unity and with gaming and stuff like that, unit tests are a little harder to do. But there's a framework for that. And before I close off the meeting, I just kind of wanted to let you guys know that there on the slides you'll see sort of a set of resources that you can look at, or not resources, I guess two videos that go a lot more in detail than what I just gave. If you're curious about taking this a little further. I listed some topics here: end substitute and humble object pattern. These are sort of topics that you can kind of search up, read a little bit about, and see how they can kind of help you in your testing with Unity. Just to give you a little context, end substitute package is used for sort of almost simulating like another module being there and providing input to your module that you're testing. So it helps out with simulating inputs coming into your module. The humble object pattern is essentially this design pattern that it's essentially a way of making mono behaviors testable with edit mode tests. It's kind of jank, like especially when you use with Unity. I don't know if I'm doing it the right way. The reason why the thing with the health stat internal and all that, that's sort of related to me using the humble object pattern, or at least trying to. But the main idea is that you sort of make this really difficult interface to work with, which is like the mono behavior interface. You turn it into something that is a little easier to work with. That's that unit tests are happier to work with. Just to give you some context on what that all is. But yeah, I hope you guys enjoyed it. Once again, testing isn't the most interesting thing in the world, but it can be very useful, especially making sure that your project is stable throughout your whole development process. But yeah, thank you guys for coming, and I hope you guys are either done with your midterms or are almost done with them. It's a little rough, week 8 and week 7, week 8, week 9. So good luck with those. And maybe we'll see you guys at the winter showcase that's coming up in well, next week. So yeah, I'll see you guys later.